Students, if you remember in the previous video, we talked about limiting reactants, didn't we? Here, we will be putting that knowledge to test and will solve a numerical question. Are you geared up for that? Let's get down to it. The question says ammonia gas, which is NH3, can be prepared by heating together two solids, ammonium chloride and calcium hydroxide. If a mixture containing 100 grams of each solid is heated, then calculate the number of grams of ammonia gas produced. Also, calculate the excess amount of reagent left unreacted. As you can observe, this question has two parts. Let's talk about the first part first. That requires us to find the number of grams of ammonia gas produced. So, before we move on to solving that, we need to look at the balanced equation for this reaction. We will have 2 moles of ammonium chloride reacts with 1 mole of calcium hydroxide, which gives us 1 mole of calcium chloride, 2 moles of ammonia gas and 2 moles of water. So, the first step is to convert the mass of both the reactants, which is ammonium chloride and calcium hydroxide, into the number of moles. And don't we already know the formula for that? Yes, we do. That is the mass of a substance divided by the molar mass of a substance. Is that correct? So, we have been given the mass of the reactant in the question. Let's start with calculating the number of moles. The mass of ammonium chloride equals to 100 grams. So, to calculate the molar mass is now a piece of cake. The molar mass of ammonium chloride is 53.5. Now, by simply using the formula, we will divide 100 by 53.5 and will get the moles of ammonium chloride, which is 1.87. Bingo! That is absolutely right. Likewise, we are going to calculate the moles for calcium hydroxide. So again, we have the mass for calcium hydroxide as 100 grams. Thus, the molar mass of calcium hydroxide would be 74. And then dividing these two values, we'll get 1.35 moles, which is the number of moles of calcium hydroxide. Easy? Now, once we have this number of moles, what we are going to do is compare these numbers of moles of the reactants with the product, which is ammonia gas in this case. So, let's start with ammonium chloride. We will write it as a ratio. Ammonium chloride is to ammonia. According to the equation that we have written says that 2 moles of ammonium chloride produce 2 moles of ammonia gas. So, 1 mole ammonium chloride would produce 1 mole of ammonia gas. Identically, 1.87 moles of ammonium chloride would produce 1.87 moles of ammonia gas. Now we are going to compare the number of moles of calcium hydroxide with ammonia gas. The equation says 1 mole of calcium hydroxide gives us 2 moles of ammonia gas. So, it is the ratio of 1:2. Hence, 1.3 moles of calcium hydroxide would give us 2.70 moles of ammonia. 1.35 will be multiplied by 2 like the mathematical ratios that we calculate. Now, when you compare both of these ratios, you will find that the number of moles of ammonia formed from ammonium chloride are lesser. So, what does that tell us? It undoubtedly signifies that ammonium chloride is our limiting reactant compared to the other reactant, which is calcium hydroxide, that is present in excess. Hence, the mass of ammonia gas produced is 1.87 moles multiplied by 17, which is the molar mass of ammonia, and we get 31.79 grams, which would be the mass of ammonia gas produced. This brings us to the end of the first part of this question. I'm sure it wasn't that difficult for you, as we have been doing similar types of questions in the previous videos as well, isn't it? Now, let's look at the second part, which requires us to find the amount of reagent left unreacted. In other words, it is basically the excess amount of reagent. Since we are required to find out the reactant which was present in excess. So as per the equation, we are going to compare these two reactants, ammonium chloride and calcium hydroxide. And we will write it as a ratio ammonium chloride is to calcium hydroxide. In the equation, isn't it visible that we have got 2 moles of ammonium chloride with 1 mole of calcium hydroxide? So, can you guess what the ratio will become? It will be 2:1. Thus, 1 mole of ammonium chloride will give us 1 divided by 2 moles calcium hydroxide, and 1.87 moles will give us 0.935 moles. Hence, we will land at the ratio of 1.87 is to 0.935. This tells us that to completely react with 1.87 moles of ammonium chloride, we require 0.935 moles of calcium hydroxide. If we now connect the dots, it will appear that in the first part we calculated the number of moles of calcium hydroxide that were taken for this reaction, which was 1.35, right? Out of that, the number of moles that was used in this reaction were 0.935, and we are left behind with 1.35 minus 0.935, which gives us 0.415. Do you understand what we did here? All we did here is just subtract the total moles of calcium hydroxide from the number of moles that were used in this reaction, which will provide us the number of moles of calcium hydroxide that were left behind after the reaction or that were left unreacted. Once we have the number of moles of calcium hydroxide that were left behind, using that, can we find out the mass of the unreacted reagent? Surely we can. What we will do is, we are going to simply multiply this number of moles with the molar mass to find out the mass of the unreacted agent. So, we have 0.415 multiplied by 74, which delivers us 30.71 grams, and that is the required answer for part 2 of this numerical.